So here in 7.10, we are talking about function operations. So we're taking functions and we are either adding, subtracting, multiplying, or dividing them. And we're also going to learn about something called compositions, composition of functions. So 5 different types of operations that we're going to do with these functions. So remember, functions are just, could be a linear function, could be a quadratic function, could be a square root function, right? But all you have to do is you have to name a function by the letter out in front. So the f, the g, and the h are kind of the names of those functions, but you could call it whatever you want. You could call it p of x, you could call it a of x, you could call it b of x. There's really no reason why I chose f, g, and h other than these are kind of the standard way we do it in algebra. But yeah, you can pick whatever letter you want and call it whatever you want. There's no specific way you have to do that. If I was doing a function about sales, maybe I would do s of x. If I was doing a function that related to the growth of a plant over time, maybe I would choose g of x for growth. So you get to choose the name of the function, but oftentimes they're just given to you. So that's what the f, the g, and the h means, just kind of the name of the function. So when we add, subtract, multiply, divide, or compose these functions, you're going to see it written one of 2 ways. You might either see it written as something like f of x plus g of x, written out all the way, or you might see it just simply as f plus g. But you have to know that these mean the same thing, all right? So f of x plus g of x means the same thing as f plus g. One thing you have to be careful of, though, is that the order does matter for some of these operations. So specifically for the subtraction, division, and compositions, the order is very important, okay? So what I mean by that is that if I take f of x minus g of x, that would give me a different value than g of x minus f of x, okay? It doesn't matter for addition, right? We know that for addition, like 5 plus 2 is the same as 2 plus 5, but it doesn't work for others of these because, again, we know that 5 minus 2 is different than 2 minus 5. Okay, one's positive, 3, one's negative. So some of these functions, like adding and multiplying, you can do it in either order. You're going to get the same thing. But we know that subtract, divide, and compositions will not quite work out that way. So we have to be careful about the order for those. So let's start off with something like f of x plus h of x. And I'm going to highlight kind of which ones we're using. So I'm going to do f of x in red. And I'm going to make g of x blue. And I'm going to make h of x orange. That way we can kind of see what I'm using for these. So if I'm going to take f of x plus h of x, I'm going to take the 3x plus 8, and I'm going to add h of x, which is x plus 3. So I'm just adding these two together, and I'm going to go ahead and combine my like terms. And so we know that 3x plus x is 4x, and 8 plus 3 is 11. So my answer is just 4x plus 11. That's it. You're just combining your like terms. All right, I'm going to take those same functions. Again, we said that g of x is the blue one. So g of x, I'm going to highlight in blue. Remember, g is the same as g of x in this case. And then f is the red one. So what I'm going to do is I'm going to take g of x, which is x squared minus 9, and I'm going to subtract f of x. Now, because I'm subtracting all of f of x, I'm going to put all of f of x inside parentheses. Okay, because I'm subtracting the whole function. So this is really the same as x squared minus 9 minus a 3x minus 8. I then want to combine my like terms, and so we get x squared minus 3x minus 17. And that would be g minus f, or in other words, g of x minus f of x. Now I'm going to take g and divide it by h. So we know that my function g, let's undo that. My function g is x squared minus 9. So I'm going to take this x squared minus 9, and I'm going to divide it by h of x. Sorry, I keep using the wrong highlighter there. Divide it by h. So we know that h of x is x plus 3. And so at the beginning here, it might not look like I can really do anything, but I actually can, because if I factor this numerator, this is x plus 3 over x minus 3. This is a difference of squares. And we see that we can cancel an x plus 3 on top and bottom. So this does, in fact, reduce to just be x minus 3. So be careful of some factoring that you could do. Problem number 4, I'm going to take f of x times g of x. So f of x is my red function, and g of x is my blue function. We know that f of x is 3x plus 8, and we know that g of x is x squared minus 9. So when I multiply these together, we will have to do some distributing, a FOIL, if that's what you're used to it being called. So we're going to go ahead and FOIL everything. So 3x times x squared is 3x cubed. 3x times negative 9 is negative 27x. 8 times x squared is 8x squared. And 8 times negative 9 is negative 72. Then I'm going to combine my like terms. So we get 3x cubed. Don't really have any like terms here, but I can write this in standard form, which would be preferred. So 8x squared minus 27x minus 72. All right, so this would be your answer. Again, trying to write that in standard form at the end. Okay, so different functions, again, you can add, subtract, multiply, divide, and then you're just going to kind of simplify, combine like term, distribute, factor, that kind of thing. Here, we are talking about composition of functions. All right, so I'm using the same functions we did before. We had g of x, we had f of x, and we had h of x. So they're the same as we were just working with. With a composition of function, what you're doing is you're taking one function and plugging it in for the x into the other function. So for example, if I wrote it like this, f of g of x, okay? I would write this down somewhere so you know what it says. But the way I would say this out loud using English is f of g of x, okay? So basically what this means is you are plugging g of x into f of x, okay? So that the function that's inside the parentheses is what gets plugged in to the function outside of the parentheses, okay? Another way to write this is f of g of x like this. You put like a little, kind of like a multiplication symbol, but you don't fill it in. It's kind of like an open dot. And so you write f dot g, and so it's f of g of x is another way you could write it. So for this problem here, we're asked to find f of g of x. Again, this would be the same thing as f of g, like that. So if I want to know what is f of g of x, that means I'm taking g of x and plugging it in to f of x. So what we're going to do is we're going to write my function 3x plus 8, right? This is my f of x. Right, there's f of x. But again, instead of just doing 3x plus 8, I want to replace that x value with the g of x. So what I'm going to do is I'm going to plug in for this x squared minus 9, right? I'm taking g of x and I'm plugging it in to f of x, okay? So what this is going to give me is 3, but again, I'm replacing the x with g of x squared minus 9 plus 8, okay? So again, g of x, this is g of x right here, x squared minus 9. I'm plugging that into f of x, all right? So now we're just going to simplify. I distribute that 3, so we get 3x squared minus 27 plus 8. And this is just going to be 3x squared minus 19. All right? And that would be your answer. That is f of g of x. For this question here, again, we're going to use the same exact functions. We've got g of x, we've got f of x, and we've got h of x. And so I'm actually going to do the exact opposite. So here I'm going to take g of f of x. So I'm taking f of x and I'm plugging it in to my function g of x. All right, again, another way to write this is g of f, means the exact same thing. So here in example 2, we're asked to find g of f. So basically, I'm taking my function f and I'm plugging it in to my function g of x. Whoops, I gotta use the highlighter there, g of x. So what this means is I'm going to take g of x, right? We know g of x is x squared minus 9. And then I'm plugging in, for x, my g of x function. So I'm going to plug in a 3x plus 8. All right? So again, I'm taking f of x and I'm plugging it in to g of x, right? Taking f of x, plugging it into g of x. So what we get from this, we do have to use parentheses when we plug in, because what's happening is we're getting this 3x plus 8 squared minus 9. All right, so again, we're taking f of x and we're plugging it in to g of x. That's g of f of x. So I just have to evaluate this. Remember that 3x plus 8 squared is really 3x plus 8 times another 3x plus 8. And so if we FOIL everything here and combine our like terms, this is going to give us 9x squared plus 48x plus 64. And then we still have this minus 9 at the end. So our final answer is just going to be 9x squared plus 48x plus 55. All right, and that would be our final answer.